In this devlog, I'm going to be creating a randomly generated passive skill tree system for my semi-open world action RPG named Anguish. My initial thoughts on creating the passive skill tree, I thought it made sense to create some type of tree structure, although this is probably obvious. After doing some thinking and planning, I decided to create one based off of my own need. For the passive skill trees in Anguish, I want there to be a bunch of different paths one can go down to unlock upgrades for their weapons. This creates a lot of weapon variation, and I believe it's an exciting way to unveil loot you've received. I really want these trees to be modular. I want to be able to support different tree depths, different total number of nodes, and even different UI layouts that can create more complex variation. I think the main benefit of this idea is you could have two different versions of the same weapon, but they could be specialized for different purposes. Perhaps one is a higher DPS output, while the other one is meant for fights where you need higher defensive stats. What I ended up creating ended up being a modified binary tree, and instead of them being explicitly connected by a parent and child relationship, I contained them within an array. The main benefit to this that I saw was that I could have direct access to the sibling nodes in each layer, and they'd be able to diverge and reform at different levels. Each level grows by one node, so each level has a maximum of level plus 1 nodes. Lastly, each level in the tree will have a lower chance to be randomly generated. This will make it particularly rare to hit higher level nodes. The randomization process goes roughly like this. First, we allocate the first node, as that is not going to be randomly generated and provides no extra stats. Then we iterate from the first level to the maximum level and randomly select the current node on the current level. Then we randomly select a node that is valid for it to connect to, so one of its children. Then we can simply do a threshold check to see if the connection will be successful. Then, regardless if it succeeded or not, we iterate over to the next level. This process is repeated until all of the total nodes for that tree have been created. Now, if we plot the generated connections, we can see how each time this creates a unique tree. For these specific examples, the variation is small, but you can see how this could scale. A problem that ended up coming up during making this was that at higher levels, the thresholds were too low and they were incredibly difficult to pass. The tree was filling up in the lower levels, and then would have to do thousands of iterations in order to pass those higher levels. The solution I came up with was to keep track of which lower levels were already filled, and then lower the threshold for the higher levels, as there was nowhere else for it to go. This ended up decreasing the generation time from 30 milliseconds to 300 microseconds. With all of the generation being done, we can now begin making this in the UI. The first thing that I needed to define was, what is a passive node? Each node contains a few properties: an ID representing its index in the tree array, the type of stat it provides, and the amount of the stat that node gives in either a percentage or as a fixed value. Due to the large amount of variation, I believe that the best way to place these nodes is programmatically. All of the nodes will be contained within a panel. I know I could have made this to be resizable using box containers, but I felt like this would go against the art style, so I decided to opt towards a fixed sizing and spacing. The first issue that I had to come up with a solution for was how I was going to actually dynamically connect the nodes to one another. My plan was to define 2 points on each passive node, one on the bottom left and one in the bottom right, that would extend the lines that connect to the next level of nodes. From here, I officially made the passive node class that extended the texture rectangle, and then I assigned the texture to it. We then can define two functions for creating these connectors. These will be called after the generation process. We can then begin creating the logic for placing these nodes on the panel. I wanted to space each level by the height of the node and then some spacing amount. Then we need to offset each level by some amount from its center, so that each level appears centered around the middle of its nodes. I can iterate over the list of already generated nodes and just place all of the connectors. When you first get an item, I felt like it would be a lot more interesting if it were to animate the tree. So I made the connectors into animated sprite sheets and swapped the functions to be a playing of an animation in the passive node. Then I iterate over the current level and play all of its connection animations, assigning their finished signal to a callback. And once that callback has received all of the connectors played, it will recursively call the animation again onto the next level until it's reached the tree's maximum amount of levels. Now we can take a look at the tree's finished animation. The next goal is to add attributes to the node and make them allocatable. The possible attributes are contained within a JSON item database where each weapon contains a list of possible attributes with some defined range in which they could be generated for. During the generation process of the passive nodes, this list is picked from randomly and then it generates the amount of that attribute it will provide. Since the passive nodes are extended from a texture rectangle base, we can hook up the mouse entered, mouse exited, and GUI input signals. This allows us to click on and hover over the nodes. I then added an allocate function, which when called will provide to the weapon the stats associated with that node. And after doing so, you'll no longer be able to allocate points further into that node. So really it just disables the allocate button. If you'd like to know further how to persist this data across saves, then refer to my last devlog where I created a save system. The last thing I wanted to do was make it all look nicer and be a bit more user-friendly to use. I added two ways to open up the passive skill tree, either by opening up the UI menu and dragging and dropping an item into the panel, or by right-clicking an item and opening its tree. I made it so instead of clicking on a node to allocate it, it brings up a details menu with a button to allocate. I then added a total bonuses section so you can see what all of the stats combined are of that passive skill tree for the selected weapon. I finished it off by making a title and the ability to pan around the tree. There's still some basic quality of life features like zooming in and out that I'd like to implement, but I feel really happy with how this has turned out. So thanks for watching, and I'll see you next time.